Hello everyone, welcome to the show. In our previous episodes, we have discussed light, mirror, and lenses. You are well aware that whenever light rays fall on a mirror, it reflects back. Have you ever wondered about the nature, effect, or cause of this reflection? Well, let's find out in this episode. The story begins in ancient times when humans first noticed their reflections in still water. Picture the awe as they gazed into ponds and streams, marveling at this mysterious phenomenon. In ancient Egypt and Greece, people observed their reflections in polished surfaces, laying the groundwork for later optical discoveries. Around 300 BCE, the ancient Greek mathematician Euclid provided geometrical insights into reflection. His work Optics discussed the laws of reflection, making an early attempt to qualify the behavior of reflected light. During the Islamic Golden Age, from 8th century to 14th century, scholars like Abu Ali al-Hasan ibn al-Haytham, also known as al-Hazan, made significant contributions to the optics. Ibn al-Haytham's work, Book of Optics, delved into the principles of reflections and refractions, laying the groundwork for later advancements. In the 17th century, scientists like Kepler and Descartes expanded the understanding of reflection. Kepler proposed that light travels in waves, while Descartes introduced the concept of specular reflection. The law of reflection as we know it today was formulated in 17th century. It states that the angle of incidence is equal to the angle of reflection. This foundational principle was independently described by scientists such as Snell and Ibn Sahal. The mathematical formulation of the law of reflection came with the work of Sir Isaac Newton. In his book Optics, Newton provided a mathematical explanation for the laws of reflection, solidifying its place in the scientific canon. Today, the law of reflection is a fundamental concept in optics. It finds applications in various fields, from designing reflective surfaces in architecture to understanding how light interacts with mirrors and lenses. This was a history of reflection. Now, let's discuss the definition and common understanding of the reflection. In scientific terms, reflection occurs when light encounters a surface and bounces back. It's akin to a cosmic game of billiards, where photons, the tiny particles of light, interact with a material surface and rebound. The angle at which the light approaches the surface, known as the angle of incidence, is equal to the angle at which it reflects. Following the laws of reflection, mirrors, polished metals, and even calm bodies of water showcase reflections in action. This fundamental process does not only allow us to see our reflection, but plays a pivotal role in optics, art, and the understanding of our visual world. In simple terms, reflection is when light bounces off the surface and comes back to us. When sunlight hits a mirror, instead of absorbing the light, the mirror bounces this back. That bouncing light is what allows us to see our reflection. Reflection is the reason we see the world around us. When it comes to reflection in optics, there are several questions that pop up frequently. Here are some of the most common ones. The first question is, what is the different types of reflection? There are three main types of reflection in optics. First one is specular reflection. This occurs when light waves bounces off a smooth surface like a mirror, reflecting at the same angle as they hit the surface. Think of a perfectly still lake reflecting the sky. That's a specular reflection in action. Second one is diffuse reflection. This happens when light waves scatter in all directions after hitting a rough surface. Imagine light hitting a piece of paper. The light gets reflected in all directions, making the paper appear bright. The third one is internal reflection. This is when light waves travel inside a material and then bounces back off its surface. Prisms and diamonds are classic examples of internal reflection. The second question is, what is the law of reflection? The law of reflection states that the angle of incidence, the angle between the incoming light wave and the normal to the surface, is equal to the angle of reflection, the angle between the reflected light wave and the normal to the surface. This law helps us predict how light will behave when it encounters different surfaces. The third question is, what factors affect the reflection of light? The types of surface, the angle of incidence, the wavelength of light, and the material's properties can all influence how light reflects. For example, a smooth metallic surface will reflect light more efficiently than a rough wooden surface. Well, these were just some of the most common questions asked about reflection in optics. By understanding these basic concepts, you can appreciate how this fundamental phenomenon plays a vital role in shaping our world and the technologies we use every day. As we have discussed different important topics of reflection, now let's find out some applications of reflection. In architecture, the strategic use of reflective surface like glass buildings not only enhances aesthetics but also regulates temperature by bouncing off some sunlight. It's like giving building a natural sunblock. Reflective paint. Ever wondered why road signs are so visible at night? It takes advantage of reflection of paint, making signs visible in headlights and contributing to road safety. In photography, reflectors are used to manipulate light, highlighting specific areas and creating captivating shots. Fiber optics. The backbone of high-speed internet, the principle of total internal reflection allows light to bounce along thin fiber, ensuring speedy and reliable data transmission. In summary, reflection is not just about mirrors and self-admiration. It's a versatile tool, enhancing safety on roads, creating a stunning architectural design, adding photography, and even revolutionizing how we connect online.